Let's take this example in which the frame 0 is the red frame and frame 1 is the green frame. And we would like to find the rotation matrix that relates, that takes a vector in 1 and represent it in 0. Okay, so you can see that this is the x-axis and this is the y-axis. So if you think of what happened, so if you think of the green frame as coincident on top of the red frame initially, then how do you reach to the pose of the green frame? Basically by rotating clockwise by 45 degrees, as shown in this angle here, okay? So what we want to do now is to get the rotation matrix, and to get that, we are going to have to find the projections of x1 onto x0 and y0. This is the first column, and then y1 as projected onto x0 and y0. This is the second column. So for the first column, we need the projection of x1 into x0 and y0. So where is that? Now this is like a triangle here. Okay, we would like to find, for example, the x-axis. So I will go a perpendicular line here to x0. All right, and then we have our triangle here. Okay, our right angle triangle, and we can apply basically the rules of right triangles. Okay, trigonometry basically. So what do we need to do is that we need the two components of x1 once onto x0 and another time onto y0. So this is a component on x0. So what is the scalar value of this? Basically, it is the hypotenuse multiplied by the cosine of this angle. So it's adjacent times it's it's basically the hypotenuse times the cosine of the angle gives you the adjacent. So we know that these vectors are basically bases or coordinates in a coordinate frame. So they must be unit vectors. So this length here must be 1. Yeah, okay. So this length now becomes 1 times cosine of 45, which is 1 over square root of 2. This is the x0 component of x1. Now the y0 component will be this one here, okay, which is in the direction of negative y0. So it has it's basically the sine of 45 multiplied by 1 basically, and that's what? That's negative 1 over square root of 2. Why did we say negative? Because it's in the negative direction of y0. Okay, it's going this way, okay, downwards. All right, so the vector, this vector here, this one, I'm talking about this one, has two components basically. The first component is this, which is in the positive x0. So that's why we have square root 1 over square root of 2. And the second component is going down on the y0. So it's going opposite to y0. So it must have a negative sign. Next, we find the y1 components. Okay, so y1 basically we need to also, which is basically the second column, we need to project y1 onto x0 and y0. Okay, so this is going to be the first component here. Okay, which is the y component, y0 component. and this is the x component, okay? This angle is also 45 degrees, okay? Because basically the y1 is perpendicular to x1, and we know that this is 45, so this must be 90 minus 45, which is 45, okay? So next, what is this now? The x component of y1 would be, again, this is 1 also, because it's a unit vector. Y1 is a unit vector. So its norm is 1. So it's 1 times the cosine of 45, which is 1 over square root of 2. And the y component is 1 times sine of 45, which is 1 over square root of 2. Okay, this is your rotation matrix that takes a vector from the frame 1, which is the green frame, to frame 0, which is the red frame. Okay, takes it from that representation to from the green representation to the red representation. I'm going to stop here and continue in the next segment.